introduction, and so I will follow Ian with perspective from an engineer's viewpoint. So welcome everybody. I'm Ashley Bateson, a partner at Hoare Lea Consulting Engineers, and I'm head of sustainability. So what I'm going to cover in this presentation is understanding the challenge, making the business case for net zero, reducing energy demand, focusing on outcomes, and verifying performance. So and we will leave some time for questions. So the place I want to start is just understanding the challenge, and I think Greta Thunberg, the climate activist, said very well last year that we need to understand the consequence of our actions, and we saw a great youth movement for advocacy of mitigating climate change. If we look at the scale of the challenge, here's a graph showing the annual total carbon dioxide increases. This is the anthropogenic emissions, so this is coming from fossil fuel combustion, and we see the steady increase since the beginning of industrialization about the 1850s, and how that's changed around the world. And with that, we've seen a 1 degree increase in global average temperatures. Now, within that 1 degree average, there's a lot of regional variations, and we see more extreme weather events, more flooding, more intense heat waves. So there's a lot of perturbations with that average. The United Nations target is that we limit climate change to 1.5 to 2 degrees since the beginning of industrialization. So look at that growth in dependency on fossil fuels and think about the challenge we need. Lots of organizations are advocating net zero by 2050. At the same time, we've got population growth. So from 4 billion 1975, nearly 8 billion now, 9.7 billion people. So we're going to see economic changes, but we need to be a lot more effective in reducing our dependency on fossil fuels. So significant change. We've got to undo what we've been doing for the past 150 years. There's a big market failure with climate change because the impacts of climate change are not faced by those responsible for the activity, partly because the impacts are faced elsewhere, and because they will be an impact in the future. A big economic study commissioned by the British government several years ago said that the cost of inaction will be overwhelming. So as engineers, as designers, we need to demonstrate leadership, working with the whole project team, working with architects, working with clients to advocate a path to net zero, accelerating the shift to low energy buildings, sharing knowledge as Ian articulated. Definitely that sharing of knowledge is a key feature of achieving better outcomes. And a focus on performance outcomes. So it's making sure that what we design is delivered in practice. So we have legislation as well. At least in the UK, it was the first country to declare net zero territorial emissions. So that doesn't include imports, but how we operate as a country. Now that's 30 years off, and we clearly need to do something before that. And this is why there's a lot of effort on projects to get to net zero much quicker, at least in new development where we can, but also existing stock. So why is the built environment so important in the discussion about climate change? Well, it's responsible for nearly half of carbon emissions, so carbon dioxide being the principal greenhouse gas. So if you look together at the residential sector and the business sector, so business being commerce, public buildings, industry, it's nearly a half. Obviously, transport is the next biggest impact, and we need to simultaneously decarbonize the transport sector. But what I'm going to focus on as a built environment specialist is the role for buildings. So the World Green Building Council is advocating all new buildings to be net zero by 2030. And a net zero carbon building is defined as a highly energy efficient building with all the remaining energy coming from on-site or off-site renewable energy sources. There are also other means of offsetting afforestation, for example, but essentially you've got a highly efficient building with the balance from renewables, and that's the new build focus, but also we need to deal with existing stock. So by decarbonising electricity generation, we can also improve how existing buildings perform and look at retrofit and refurbishment as well, which is a massive challenge, but an opportunity for the supply chain to get involved. So it's always worth clarifying what we mean within the scope of net zero carbon. So the UK Green Building Council published a framework on this, and it defines operational carbon as the energy in use and the inclusion of any renewables, and the embodied carbon, which Ian spoke about, that's the pollution that comes from the construction process and replacement and refurbishment. And when you look at the whole of that, that's the whole life carbon. So this is a typical analysis of building over 60 years. So approximately half of the whole life carbon starts from day one of occupation, because that's embodied in construction. So this will look different for different building types. It will look slightly different for schools, for homes, for a research building. But generally you get this pattern of the operational carbon increasing and the embodied carbon in use being replacement of parts. So we want to tackle all those elements. And here's a breakdown of embodied carbon, showing on the left-hand side the substructure and the superstructure, really dominant there on embodied carbon, and that's largely as a result of concrete and steel in construction. And the more you can do to reuse a structure, obviously the more avoided carbon emissions there are, and then other components like the envelope and the building services themselves have an embodied carbon element. And then on the right hand side, this is analysis for an office. So the tenant in an office is responsible for about half with IT and appliances, and then the landlord system, such as the lighting and the ventilation systems, are also responsible for about half of operational carbon. So that provides an overview of all the things we've got to tackle to reduce carbon emissions in the built environment. At the same time, we have to deal with adapting to a different climate. So not only are we aiming to target more efficient buildings, we've got to deal with potential overheating, more flooding and designed buildings to accept that. So a big challenge in building design is how do we design to avoid overheating and more heat waves without the need for air conditioning. So it would be a simple response to say put more air conditioning in, but that is an energy load. So we need to look at passive means, alternative means to achieve comfort, and we're seeing lots of implications in schools, for example, in apartments where there's just challenges for removing the heat gains. Now, what about the commercial implications? So there's an estimate from the Committee on Climate Change that a net zero commitment could be met by an annual resource cost of 1 to 2% of GDP. This was announced before the current situations that internationally we're dealing with. I mean, for a comparison, that's less than what an industrial nation might spend on defence, blown out of proportion by what we're dealing now with COVID impacts on the economy. So in the scheme of things, 1 to 2% of GDP did seem like an affordable contribution to be net zero. We find as consultants working with property developers and public bodies, it's really important to understand the business case. What drives the funder of a project to consider net zero, because many clients are not considering net zero. So we think it's important to demonstrate the co-benefits of getting to net zero and climate conscious design. So we often talk about the government drivers. So we've signed up to the Paris protocol to limit climate change. There will be regulation changes. The government's reviewing planning. So we talk to investors about being resilient, so that the investment in a property is future-proofed. For building owners, it's important to connect with them on the long-term value of the property, and why it's important to manage performance expectations. And also, tenants are increasingly asking for efficient operation, and people that own buildings that have a workforce want to address the needs of occupants to align with values of corporate responsibility and sustainable responsibility. So these are the kinds of drivers we often talk to clients with to demonstrate the business case. So we have just to iterate on the government perspective, environmental plans, recently issued 10-point plan for the green economy. So it's important for people investing in projects to realize that the landscape's changing, and we need to protect buildings for these changing regulations. A lot of funders and investors are also interested in their environmental, social and governance policies, and connecting development strategies with United Nations Sustainable Development Goals. And big pension funds and developers are often benchmarking themselves using the Global Real Estate Sustainability Benchmarking System, GRESB. So that supports efforts to reduce carbon emissions. We do see emerging guidance and standards on better performing buildings. So specifically, the Better Buildings Partnership is issuing guidance on energy for offices, and that's a validation process where the project team agrees an energy target, and that is validated in use. So this is getting away from a construction standard and more into how's the building actually going to perform in practice. So verifying energy use one year after occupation. And there is indication that sustainable buildings have higher value. So a study from the agents JLL indicated that sustainable buildings could attract a rental premium 6%, 11% higher, at least in the London market. So that shows that those investing in sustainable low energy design could get better return. And the industry is coming up with targets for reducing energy in operation and in embodied carbon targets. So the table here is taken from the RIBA 2030 Climate Challenge, and that shows what we should be doing in increments up to 2030 to get to this efficiency standard. And the changes that can be made, here's a typical cross-section of perhaps a modern office, might have 80% glazing ratio, gas heating as a standard, suspended ceilings, and lot of material in the building really. If we go to the stretch target of this RIBA 2030 challenge, we will tend to find that there'll be less glazing because that will limit heat gain and heat loss, probably more solar shading, remove some of the materials such as suspended ceilings, go away from gas heating to heat pumps, so that's a lower carbon heat source. And as part of a study with the Green Building Council, we evaluated with cost consultants the cost impact of that. There is a capital cost increase, so to get to that 2030 net zero target, at least for a commercial building, there could be a capital cost increase of more than 8%. But I think as the supply chain gets better informed and can do it more efficiently, we might see the capital costs come down. So I think it's important to recognise the reality that more work has to be done on getting the costs down. So very much, as Ian says, that we need to focus on working together and look at the interdisciplinary nature of building design. The performance gap still exists. Here's a comparison of energy use from a range of offices where we have the energy ratings, which is the energy performance certificate. That's a theoretical rating, and each of the grey lines here represents measured energy. So you can see for example, a C-rated office, there's a big diversity in energy use, and for an E-rated office, there's also a big range of energy use there. So there are massive performance gaps, and measured energy is very different from the theoretical energy. So the design for performance strategy, which emphasizes this need to validate outcomes, is very important. And what we'll find is more early analysis on projects, looking at the building form and fabric, and passive strategies, blue-green infrastructure. That means looking at the landscape and surrounding of buildings so we can optimize the climate. Here's an example of a building we did for the Environment Agency, which halved the energy consumption compared to a good practice air conditioned office, simply by having shading, better controls, a ground source heat exchange system. And we, looking at the bigger picture, with the decarbonisation of the grid and moving towards electric vehicles, we can see that the whole infrastructure really should work in this electric future of electric transport and electric buildings. So just to finish off on embodied carbon, massive global impact coming from concrete and steel. Concrete and steel each responsible for about 7%, 8% of worldwide emissions. So key lessons are use less, fewer finishes, exposed surfaces, robust materials, and impacts for the industry on how we perhaps define beauty, how we manage occupant expectations. Materials will be different, the management of the building will be different, and reinforcing the need to verify outcomes and post-occupancy evaluation, and just the feedback loop of measurement, verification, and continually improving design. Thank you very much.